I need to true the base of the flange. Here I am turning an arbor. The chuck will be tightened onto this arbor and the flange base faced. The chuck flange is a sliding fit in the housing. The 4 adjustment screws are tightened to hold it. I shall next transfer the 4 holes in the housing flange onto the chuck flange. Here I am using the holes in the housing as a guide to drill matching holes in the collet holder flange. The holes in the collet holder shall be threaded M6, whilst those in the housing shall be widened to 6.5 mm. The collet holder flange outer diameter shall be reduced by ½ mm. This difference in dimensions allows the chuck to be adjusted radially. The collet holder backing flange is threaded M6. Here I am widening the housing flange holes to 6.5 mm. The collet holder backing flange is a sliding fit in the housing, but not for long. Tightening the collet holder on the previously turned arbor allows me to reduce slightly the outside diameter of the flange. I cannot use the ER wrench and had to resort to a post spanner to tighten it. The outside diameter of the flange is reduced by ½ mm. The collet holder flange now is a loose fit in the housing. Here is the chuck ready to meet the mill. The flat on the chuck taper needs to be aligned with the slot on the mill spindle. In this position, the taper engages the internal key in the spindle bore. The drawbar is then inserted in the spindle to hold the taper in place. I have since replaced this drawbar to a more convenient one, that can draw in the taper and also eject it. Here I am dialing in the set true collet chuck. The runout is around 0.3 mm. The 4 screws need to be loosened and then tightened just a little. This allows the adjustment grub screws to move the collet holder axially. The set true chuck is adjusted like a 4-jaw independent lathe chuck. First, one of the grub screws is aligned with the dial indicator and zeroed. The opposite grub screw is then aligned with the dial indicator and the reading noted. These grub screws are adjusted so that the dial indicator reads half the reading. The chuck is rotated by 90 degrees and the grub screws are adjusted till the dial indicator reads 0. After a little fiddling, the chuck is dialed in to around 0.01 mm. Good enough. Now to see how it performs. After the chuck is dialed in, the 4 retaining screws are tightened. I fitted a 20 mm end mill to cut a 15 mm thick piece of steel stock. The cutter is also engaging the stock at its lowest part. The cut is 0.5 mm deep and I am cranking fast. See how the chips fly. Here you can see how deep the cut is. The collet chuck has passed the test. I set the end mill just a squeak above the bottom of the stock to test if the end mill would be pulled down. And it also passed this test. Looking good. Another challenge completed successfully.